Hello everyone, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the live chat. And then we are going to begin the live session on engineering mathematics from today onwards. So let me briefly discuss about the idea how we are going to carry out our engineering mathematics. The first and foremost thing, as the videos are supposed to come in our Gate Academy Global, that means my mode of communication is going to be completely in English only. But I feel the student who are been from the northern part of our country, who are been more acquainted with Hindi, they will also be able to follow my complete engineering mathematics. The next important point, the many of the student would have one doubt within their mind, and that had been, sir, which are the different branches we are going to cater over these videos? All of the branches. So you can say almost all of the branches would be covered within the series of the live videos which we are going to begin from today onwards, which includes electronics obviously, then electrical, then instrumentation, then mechanical, then civil, then chemical, then PI, then computer science, then now even we have the agriculture, so on and so forth. So you can say what are the different streams which are having the engineering mathematics in their GATE syllabus, those all parts are going to get covered. Agreed? The next important point, the schedule. As far as the schedule is being concerned, I would be live on daily basis precisely at 7:30 p.m. So approximately at 6 p.m. we start aptitude. The aptitude lasts approximately 1 hour, 1 hour 15 minutes. So probably you get free around at 7:15. So you will have approximately break of 15 minutes, and then we are straight away going to jump over the engineering mathematics. And as far as the amount of time which we are going to spend in daily basis, approximately 1 hour. That means my lecture is going to begin at 7:30 and it would last approximately at 8:30. So without haphazarding your complete daily routine, you can simply sit at 6 p.m. 6 p.m. would be the part of aptitude, and similarly at 7:30 to 8:30, now you are also going to enjoy the mathematics as well. Now the next important thing, why we had designed this course structure, because you guys are well aware there are been the fixed marks from these two subjects. The first has been aptitude. The 15 marks are been fixed from aptitude, and similarly from last 2 year onwards it had been clearly indicated over the syllabus the 13 marks approximately has been fixed from engineering mathematics side, and once you add them together the marks goes somewhere 28 marks out of 100 marks. That means you are going to ensure approximately your 28% max. And once you'll go into the history of GATE, you will find somewhere approximately at 30 marks, 25 marks, 35 marks, you get the scorecard. So what I'm saying, if you are comfortable with this two subject, nobody can stop you to get the scorecard. And if you are been well prepared with your technical subjects as well, definitely this 28 marks are going to be a very crucial marks for all of the engineers who had been preparing for GATE from either of the branch, from electrical, from electronics, from any of them. Yes. The next important point, when I was designing this course, there are so many things which were going in my mind. Which topic should I be starting? Should I be completing the complete syllabus? How much time I should be taking in each day? How much time I should take this complete engineering mathematics? There were several number of doubts I was going in my mind. But at least I could conclude few of the important things. Now, whether I would be covering the complete engineering mathematics or not, that would completely be dependent on you guys. And that would be decided by the crowd. But still, the two important topics I am going to cover into the great detail, which starts from probability, and then I would go into the calculus. And as far as these two topics are being concerned, I can say they are been the heaviest most topic from the engineering mathematics, and approximately you can say 70% marks comes from this two topic. And if the crowd is being maintained, definitely I would cover the complete engineering mathematics parts itself. Now, my first topic, which I would begin from today onwards, is going to be the probability. And once we are done with the probability, we will go forward and we will talk about the calculus as well. And whatever the topic I'm going to take within this series, no, I would go into the great detail. Not even a single question you will be able to leave in your GATE examination. We will try to understand about its theoretical understanding. We will try to understand its application. We will take plenty number of questions which had been self-designed question by me, and similarly few number of questions from the GATE side. Put together, there would not be any leakage of marks from the topic which we are going to study from this series of engineering mathematics. So I don't find any of the student would have any kind of doubt. The first thing had been clearly communicated. As the videos are supposed to come in our GATE Academy Global, so obviously my mode of communication is going to be English. What are the different branches which I would be catering over these videos? Almost all branches where the engineering mathematics has been the part of their syllabus. Either you take either of the branch, definitely the probability and the calculus has been the part of their syllabus. Similarly, what about the time? Precisely at 7:30 we would get live, and approximately my lecture would last for 1 hour. Put together 7:30 plus 1, 8:30 you guys would be free. And as far as the marks distribution is being concerned, already aptitude classes are started probably 1 month back, and it had been keep continuing. So 15 marks is going to get frozen from that video, and similarly 13 marks is going to get freeze from my side. Put together, you had been well prepared for the 28 marks. And as far as the topics which I am going to cover over this sequence of videos, definitely probability I am going to cover completely. Not even single important point would be left out. And at the same time, we will also be discussing about the calculus. Either it's been the integral calculus, either it's been the differential calculus, either it's been the vector calculus. How much time I am going to take? Probably this complete lecture may go only these two topics 70 hours, because as far as my technique of teaching mathematics is concerned, approximately my length of videos used to be 150 hours for the complete mathematics. No, sorry, these videos are going to be completely open, so definitely you can watch after maybe 5 hours, maybe 5 days. No, I'm not going to make it private. So let me focus over the agenda behind today's topic. From today onwards, we are going to start the probability. We are going to start the probability. But as far as the probability as a topic is being concerned, there are so many subtopics are being involved with this topic, which includes permutation and combination, which includes the problem based on word problem, which includes permutation and combination, which includes stats, which includes probability density and distribution. So what I'm going to do, the complete part of probability, I'm going to bifurcate into the 2 to 3 number of subparts. At very beginning, we will be focusing over permutation and combination. This would be the first topic within the probability. In the same sequence, the second topic which we are going to cover is going to be the word problem. And once we are done with the word problem, we would go forward and we will be talking about stats. Although stats is not necessary because it had been a separate topic, but stats has been taught over the probability itself, because until and unless you do not exactly know about the mean, variance, you will not be able to use those tools over the probability distribution and densities, which are been the very important parameters of the probability distribution. That is why the stats part would also be covered within the probability itself. And then we will be talking about the probability distribution and density. And specifically here in probability distribution and density, I'm going to spare a good amount of time, because I can understand most of the students do not exactly understand the practical meaning of the probability distribution and density. They do not able to feel why the probability distribution and density fundamental had come. Density. Yes. So let me check the comments from you guys. Swarit had followed my earlier lecture as well. Thanks Swarit for support. कृष्णा रावल सर CSIR नेट के लिए भी हेल्प करेगा, ऑब्वियसली करेगा, डेफिनेटली इट इज गोइंग टू हेल्प द CSIR एंड नेट एज वेल. Okay, so let me begin. My dear friend, before starting this subject, let me have a practical understanding of the probability itself. May I know why this topic probability is being introduced? Nowhere you will be finding in real life that you and might be your sibling are been playing with a ludo or dice of a ludo, and then you had been finding the probability for getting 1, probability for getting odd, probability for getting even. No, nowhere in practical situation you find that. But still we are been so curious to calculate the probability for occurrence of a certain event. May I know why? What is been the actual practical meaning of the probability? My dear friends, the big finance companies, big life insurance companies, they all are been working over the probability, and even they are able to manage the earning of their from the probability itself. Just take an example of LIC itself, Life Insurance Corporation of India. What they do? They give a policy. After death, you can claim this much amount of money from your family side. And keep in mind how long you will be alive. When you are going to die, they all are been uncertainties, or I can say they all are been probabilities. But still they are able to manage the mathematics behind the probability. And one thing has been quite sure, the most uncertain thing is been nothing but life. Still they are able to manage the mathematics behind the uncertainty of the life of a person, and still they are able to manage such a big number of people within the same corporation. Anyways, this is all about the probability itself. This is all about the probability itself. Yes. Anyways, the practical aspects of the probability would be revealed as we will go part by part in one topic to another topic. So I think it has been the right time we should be focusing straight away over the first subtopic of the probability, and that had been permutation and combination. And combination. So the topic which we are going to begin from today onwards is going to be the permutation and combination. Permutation and combination. Write it down. So this is going to be the first subtopic which we are going to begin from today onwards. No issue, Ravi Kumar. If you watch my complete video, you will not have any doubt as such. Now, many of the students might be thinking, sir, why did we start from the permutation and combination? As you are telling that the topic which we are going to cover, the probability, from where the concept of the permutation and combination had come within the probability. There are several kinds of the problem where the probability has to be found, but finding the probability becomes very difficult until and unless the concept of permutation and combination is not been clear to all of us. Even I had seen many of the times the student had a fear factor. Sir, in this particular problem, should I be using the permutation or should I be using the combination? And most of the time, the student are not well aware with the practical understanding of the permutation and combination. Let me show you a few number of examples. Easily you will be able to understand what exactly I had been talking about. Just a minute. If I take few number of questions and let me show you how the permutation and combination has been so important. Questions. Permutation, yes. you will find this kind of the problem repeatedly. A bag contains 7 number of balls. Out of them, 3 balls are black, 2 are blue, and 2 are red. Find its probability if 2 balls are withdrawn simultaneously, or both are black, both are red, one black, one red. So what had been happening? You had a certain number of collection, and within that collection you had been withdrawing, you had been selecting, you had been collecting few number of items, and there the probability is being involved. My dear friend, whenever you had n number of items and there the methodology of selection, collection or ordering is being taken place, by default that problem can be brought easily into the domain of permutation and combination, and easily it can be smashed there. Did you understand which kind of the problem is being easily solved with the help of permutation and combination? The problems where the combination or maybe selection, maybe collection, maybe ordering is being involved. As you can see very well, as you can see very well, in this bag 7 number of balls, out of them the 3 black balls, 2 blue balls and 2 red balls are being there in their part, and now they had been selecting few number of balls out of it. Similarly, you can have the next problem as well. Again the 7 number of balls we had, and now we had been selecting few number of balls out of 7, maybe with replacement, without replacement. Those part we are going to study later on. So this many questions are being the problem from the concept of permutation and combination, which can be easily cracked with the help of this concept. Agreed? Okay then. Let me start with combination. Let me start with combination. Write it down. I would request to each one of you, write it down along with me. As far as the symbol for the combination is being concerned, it is being defined as NCR. NCR. Where the NCR or this symbol indicates number of ways our items can be selected, or our objects can be selected, collected or can be withdrawn out of n number of items. N number of items. N number of items. So NCR symbolically calculates how many ways R number of items can be selected, can be collected, can be withdrawn. There have been different methodology for the same problem, no? Either you might be collecting something, either you might be selecting something, either you might be withdrawing few number of balls from a certain bag. So you need not to have any doubt over here. Selected can also be referred somewhere from collection, collected. This word could have been connected to the collected, or could have also been connected to the withdrawn. Yes, this has been the first important point regarding the combination. May I know what would be the N and R? As we had been talking about the number of items, let's take out of n number of items, R number of items are being selected. So here the natural counting we had been talking about. So obviously n and R can't be negative, and even they can't be the rational number as well. Put together, as far as the n and R is being concerned, they would always be a whole number. Do you have any doubt in it? No, sir. You can have a situation where you had a box. Within a box, 3 number of balls are being there. Now I want to ask how many ways the 2 balls can be withdrawn, can be collected, can be selected out of 3 number of balls. Definitely the second problem, second way of asking the question could be, if you had a bag there, let's take you had a 10 number of pencils, how many different ways the 3 number of pencils can be selected. So as far as the total number of items are being concerned, that is being defined as n, and keep in mind that n would always be a whole number. It can't be half, it can't be -1, it can't be 3/2. It would always be a natural number which includes 0, 1, 2, 3, 4, so on and so forth. And similarly, out of n number of items, the R items are being selected. That means the R is also going to be a whole number only. But as the R is being the subsidiary of n, out of n number of items, the R items are going to be selected. So obviously the R is going to be lesser than equals to of n. Like, you can have an example. A box had a 3 number of balls. How many ways one ball can be selected? 2 ball can be selected. At worst, 3 ball can be selected. You cannot have a problem. How many ways in a box the 3 balls are being there? How many ways the 4 balls can be selected? So one thing has been quite sure, as far as the n and r in being concerned, they would always be a whole number. They can't be like 3 by 2. They can't be like a -1. They can't be like a -2. Practically, there does not had any meaning at all. Yes. So from here onwards, you can have one understanding. As far as any sort of combination related problem is being concerned, n and r would always be a whole number at any cost. At any cost. In the same sequence, the next important point which we can write over here is being r would always be lesser, at worst is equals to n. May I know what had been the n over there? The n is been total number of item and r is been the number of collected items. R is been the number of collected items. Did you understand what I am saying? So let me write it down over here. So as far as the n is being concerned, as far as the r is being concerned, the n is being total number of items. Total number of items. And similarly r is being number of selected items. Selected items. Number of selected items. Yes. Now in the same sequence, let me move forward. Even the value of NCR would always be a natural number. Would always be a natural number. You can't have a mathematical equation NCR which leads a number like -1, -2, 1/2, 3/2. No, that is not at all possible. Why? What the NCR talks about? The NCR talks about the number of ways. How many number of ways we can do that particular collection, selection, or withdrawal. So obviously, if I talk about the number of ways, it could be 1 way, 2 way, 3 way, 4 way, 5 way, so on and so forth. So one thing has been quite sure. It would always be a natural number. You cannot expect any of the irrational number, maybe any of the negative integer out of the calculation of NCR. Out of the calculation of NCR. As far as the formula of NCR is being concerned, at last we will also derive this formula as well. The NCR is being defined as n factorial divided by of r factorial into n minus of r factorial. N minus of r factorial. N minus of r factorial. Have you written each and everything which had been written over here? I would like to have the input from each one of you. Have you guys written each and everything? Now, in the next step, we are going to focus over few more important properties followed by combination. Again, NCR which we have written over there, NCR is equals to n factorial divided by of r factorial into n minus of r factorial. N minus of r factorial. N minus of r factorial. Okay, then let me move forward. The next important point, then what had been the difference between the combination and permutation? My dear friend, whenever only and only the discussion of collection, selection or withdrawal is being taken place, we would be focusing over the combination. But along with withdrawal, maybe selection or collection, even the order makes also sense. In that case, the permutation do come into the picture. Let me take few number of examples. With the help of that, we will be able to clear that the problem is being based on the concept of permutation or the combination. So keep in mind, where the ordering does not make sense, there the concept of combination do come into the picture. Order no means. Order no means. Whereas in case of permutation, even if we have collected two number of items, let's take they had been arranged and the first item is been, let's take A, second item is been B, but in second trial, if the first item is been B and second item is been A, they would be counted as a two different orders. Did you understand what I'm saying? So whenever there had not been any meaning of order, keep in mind that problem by default comes from the problem of combination. Comes from the problem of combination. So let me focus over the important point which we had discussed so far. As far as the combination symbolic representation is being concerned, it has been defined as a NCR. How the NCR is being understood in terms of its definition? Number of ways R items can be selected, can be collected, can be withdrawn out of n number of items. As n and r are being countings, definitely they can't be negative integer, they can't be 1 by 2, they can't be 3 by 2. Obviously they had to be a whole number only. So from here onwards, one thing must be there in your mind, that the n and r at any cost can't be anything apart from the whole number. Next, out of n number of items, we are going to select, collect or withdraw r number of items. So r is supposed to be lesser than the n. But at worst or the worst condition, you might be collecting or selecting all n number of items. In that case, even the r could also be as same as n. So keep in mind, as far as the mathematical equation is being concerned, r would always be lesser than equals to of n. Next, NCR, what it talks about, the number of ways. So obviously number of ways could be 1, 2, 3, 4. So the result of NCR would always be a natural number. How mathematically NCR is being defined? The NCR mathematically is being defined as a n factorial, where the n is been the number of items divided by of r factorial, where the r is been the number of items which are being collected into of n minus of r factorial. Many of the students used to have one doubt, sir, from where this outcome or the formula had come. Anyways, once we will be forcing the permutation part, we will also come into the picture from where this derivation had come into the picture. Derivation had come into the picture. Agreed? In the same sequence, now the next doubt used to come in our mind, sir, then why permutation had come into the picture? My dear friend, whenever simple collection, simple selection, simple withdrawal is being taken place, we focus over the combination. But after selection, collection or withdraw, even the ordering do also make sense. In that case, the permutation do come into the picture. Permutation do come into the picture. Did you understand what I am saying? Did you have the idea about it? So let me take few number of problems. Let me take few number of problems. The first problem. Let's take, you have three persons A, B and C. Let's take you have three persons A, B and C. I am asking a question, how many ways two persons can be selected without repetition. And as far as this problem is being concerned, nowhere it had been written that their order do also make sense, whether the A had come first, whether the B had come first, whether the C had come first. No, it's just been merely a selection or collection. So the solution do starts from here. My dear friend, at very beginning, we are going to have the two number of blocks. Why we are going to have two number of blocks? Because out of three number of person, we are supposed to choose only and only two person. So in first block, how many total possibilities you had? You can select either of them. Either you can select A, either you can select B, either you can select C. So 3 number of possibilities we had over here. That is fine, sir. That is fine, sir. But if one person is been fixed in first block, we had been left out with only and only 2 possibilities. So how many number of possibilities is been left out for the second block? Is only been 2. It's only been 2. Agreed? No? So may I know total how many ways the selection can be made? And that could be 3 into 2, 6. I can understand many of the students would think, sir, why the addition had not been taken place. My dear friend, here the addition would not take place because the tree structure has been formed over here. What does that mean by the tree structure? What I'm saying, the 3 different ways this first block could have been filled. The first block must have been filled with A, might have been filled with B, might have filled with C. Agreed? If the first block had been filled with A, the second block has been left out with either B or C. Similarly, if the first block is been filled with B, the second block is been left out with A and C only. A and C only. And similarly, if the first block is been filled with C, now you had been left out with A and B only. A and B only. Agreed? Agreed, my dear friends? Yes, sir. So now what had been happening? Let me write them together. See what had been happening. So A and B has been the first selection. A and C has been the second selection. Then B into A or BA is going to be the third selection. BC is going to be the fourth selection. CA is going to be the next selection, and CB is going to be the last selection. Now I would like to ask from each one of you, how many ways the 2 persons can be selected out of 3? So answer has been 6, but this is not the genuine answer. This has not been the genuine answer. Why? Because I had just been talking about the selection of the people. AB, whether the A had come first, whether the B had come first, whether the B had come first, whether the A had come first, hardly makes sense, at least in this problem, because the ordering had not made any impact over this problem. So don't you think so that the AB and BA would be counted only as 1? Obviously, sir. So what had been happening over here, the AB and BA would be counted as 1 only. And same goes with the AC and CA as well. AC and CA as well. CA as well. Agreed? And now BC and CB as well. So if you want to link, we can link it over here. So AB and BA would be counted as 1 selection because their ordering, at least in this problem, hardly makes sense. AC and CA would be counted as 1, and BC and CB would be counted as 1. Would be counted as 1. So how many ways it had been? So it had been 1, 1, and 1. This has been 3 ways. So the 2 different outcome had come. When the order do make sense, keep in mind there are 6 different ways the people can be selected. If the order do make sense, and if the order do not make sense, the 3 different ways the people could have been selected. How? Either I could have selected AB, either I could selected BC, either I could selected AC. So here, straight away I could have taken the situation. I have selected AB, that means A and B had come together, BC and AC. Could you understand what I am saying? So as far as the same problem is being concerned, the first answer which we had calculated, no, here the selection or collection is being taken place when their order do also make sense. So this has been the problem of permutation. And here only and only selection part is being taken place. So this has been a problem of combination. Yes. So may I know what was the formula for the combination? As per the formula, how many are different items can be selected out of n number of items? So may I know how many number of items we had? The 3 number of items we had. Yes. 3 number of items we had, and we wanted to know how many ways the 2 items would be selected out of 3. And how it would be written? N factorial, that had been 3 factorial, divided by of r factorial, that had been 2 factorial, n minus of r factorial, that is been 3 minus of 2 factorial. What used to be the 3 factorial? 3 factorial is simply been 2 into 3, and 2 factorial simply been 2, 1 factorial has been simply 1, 2 and 2 is going to go out, and the result which we are supposed to get, it's been simply 3. Agreed? So I would like to have the input from each one of you. Did you really understood what exactly had been talked of? And if you will find the permutation, the formula of NPR used to be n factorial divided by of n minus of r factorial. And how the permutation is being defined? The permutation is being defined as how many ways r items can be selected and ordered out of n number of items. Let's take n, how many number of people or the item we had, the 3 number of item or people we had, and towards denominator side we had 3 minus how many collections is being taken place, and that had been 2. So 3 minus of 2, that is been simply 1 factorial. So 3 factorial has been 6, and divided by 1 factorial, it remained 1. It remained 1. Agreed? So let me take few number of problems. How many ways? How many ways? How many ways? Final 11 players can be selected. Final 11 players can be selected. Can be selected. Out of 15 players. 15 players. I would like to have the input from each one of you. Tell me what would be the best most answer for this given question. See what had been happening in year of 2023. Probably T20 World Cup is supposed to take place. Where it is going to happen, I exactly do not know the venue. So let's take the Indian cricket team had finalized the 15 number of players which had been going from India to that venue, and out of 15 number of players, the final 11 players has to be selected. May I know how many ways that final 11 players can be selected? How many ways the final 11 players can be selected? And I would request to each one of you have the calculator in your hand whenever you attend my class, because my class would not be only and only for the entertainment and the enjoy purpose. You will also get few of the crux, and which would be very helpful for your GATE examination. So I would like to ask from each one of you whether this has been the problem of permutation or combination. Each one of you, whether this has been the problem of permutation or combination. This has been the problem of permutation or combination. I would like to have the input, that means the number, and at the same time I would also like to have the common understanding whether this has been the problem of permutation or combination. Permutation or combination. The one answer had come from Krishna. The Krishna is saying it's been the problem of combination. Gautam Das, Ravi, permutation. No, my dear friend. So whoever having the doubt that it's been the problem of permutation, no, my dear friends. Out of 15 number of items, why I had used the word items? Because here it had been players. Somewhere it could be number of balls, somewhere it could be number of apples, somewhere it could be number of bananas. So in totality or in generality, rather calling it players, rather calling it apples, rather calling it bananas, I had just been talking at items. So how many number of items we had, my dear friends? 15 number of items we had. Out of 15 number of items, we are going to select the 11 items. There no talk about the order had been taken place. So what does it mean of it? That means straight away we can say this has been the problem of combination, sir. Need not to worry at all. This has been a problem of combination. So one student had one doubt. Anyways, I am going to rephrase this problem once again, and deliberately I would convert this problem into the problem of permutation. Yes. So out of 15 number of items, we are going to select, we are going to collect, we are going to withdraw 11 number of items. And the result which we get, it's been huge. It's been huge. 15, C has been here. Yeah, C11. And that had been 1365. That means out of 15 number of pool, if you had to null down the 11 number of players, that had been a too hectic task. In my time, when I used to watch cricket regularly, then I used to curse management and captain like anything. Why he had dropped Venkatesh Prasad, why he had dropped Javagal Srinath. But keep in mind, the selection process is not that easy process. How many ways he could have selected a unique team? 1365 ways. Such a haptic permutation and combination fundamental that selector, that captain has in their mind. So obviously, whatever you think that this is going to be your final cricket team, that is not going to happen, because you will say this has to be a final 11 playing team that had been one combination out of 1365. That's been huge now. That's been huge. Did you understand? So from here onwards, will you abuse selector? Will you abuse captain? No. If you really knows mathematics, you cannot abuse or you cannot curse any of the selector or any of the captain, because there had been 1365, 1365 different ways a unique team could have been selected out of 15 number of backup players. That's been huge. That's been huge. So from here onwards, nobody should curse or nobody should abuse. Probably now the team is being Rishabh Pant is being captain, no, but nobody should abuse Rohit Sharma during World Cup, because the selection is not been an easy task. And being a engineering student, being a student of engineering mathematics, you can really enjoy, sir. It is not that easy. It is not that easy. Now, one of the worst thing I am going to do, it will really blow your mind. In my time, literally being a child, I was abusing selector and captain, not only for the selection, even the ordering of the batting. In my time, usually the Sachin was coming at third down, but after some amount of time, when the Saurav Ganguly became captain, now he was the opener batsman. So now the situation has been changed a bit. How many ways the final ordering of the batting can be made out of 15 players? What I'm saying, not only you had to select the final 11 playing team, even you had to order them together. How many ways? How many ways? Batting order. Batting order. Batting order can be made out of 15 players. Made out of 15 players. Anyways, I would like to have the input from each one of you, whether this has been a problem of permutation, whether this has been a problem of combination. What is the time of course? Exactly daily basis at 7:30 we are going to get live, and it would last till 8:30 somewhere. 8:30 somewhere. Yes, Rahul, that is called dependent event. May I know whether the permutation would be used or the combination would be used? One thing has been quite sure. As far as the cricket as a sports is concerned, only and only 11 players get selected. So if you are going to arrange the batting order, first you have to pick 11 player out of 15, and even their ordering would also make a different bunch. Would also make a different bunch. So may I know whether it's been the problem of permutation or whether it's been a problem of combination? I would like to have the input from each one of you, whether it's been a problem of permutation or combination. Yes, my dear friend, here the selection and ordering, both processes been intacted in the same problem. Obviously, this has been a problem of permutation. This is been the problem of permutation. This is been the problem of permutation. Agreed? So mathematical symbol is being concerned. Out of 15 number of players, not only I am going to select 11 players, even their ordering or also making sense. So here the formula which had come into the picture, it's been 15p11, 15p11. And now if we'll talk about this value, it has been huge actually, 15p11. You will get in 5.44 into 10 to the power of 10. Now tell me, such a huge task it had been. Now it had understood like that. It had been equally distributed, or it had been equally probable that any of the player could have been selected and any of the player could have been sent for middle order, any of the player could have been sent for maybe beginner, any of the player can be selected as a talender. In that case, how many ways that final batting order can be made? So out of 15 number of players, you are going to null down 11 number of players, and out of 11 number of players, by shuffling their locations, again you can make this many number of batting order. Such a huge challenge it had been. So I would request from each one of you, from here onwards nobody should curse any of the captain, because it had been a so huge task. Now I would like to understand from where this concept had come. 15c1 is been 1365 and 15p1 is been 5.44 into 10 to the power of 10. Anyways, how 15c1 must have been calculated mathematically? It is been n factorial. Divided by of r factorial, that is been 11 factorial, into of n minus of r factorial, that is been 4 factorial. Yes, सब करना पड़ेगा. And here this has been 15 factorial divided by merely it is been 4 factorial. Did you had an idea about each one of you? So I would like to ask from each one of you, till this point each and everything is been clear, because once again I am going to refresh the things which we had studied so far. And as I am saying, as I would go into the great detail, the each topic would take approximately good amount of time. So again, I am saying how much topic I am going to cover, that would be completely dependent on your reply as well as the crowd which we had over the live session. Yes. So let me focus over the permutation part as well. Yes. So let me focus over the permutation part as well. So let me put the heading as permutation. Symbolically, the permutation would be referred by NPR. Instead the NCR, now it had been referred by NPR. That has been the first important point regarding the permutation. As far as NPR is being concerned, mathematically NPR is been written as n factorial divided by of n minus of r factorial. Next important point. What had been the n over there? The n has been total number of items. And R is been the collected items. R is been collected, selected or withdrawal item. Collected, selected or withdrawal item. And what the NPR talks about? Number of ways, as we had done it earlier. Number of ways R items can be selected and ordered out of n number of items. Out of n number of items. Yes, sir. Aruna, definitely I am going to plan for the EMFT as well. Need not to worry about it. So let me focus over the different slides which we had covered so far. As far as this topic probability is concerned, we are going to understand this concept of probability into the great detail. The complete probability has been bifurcated into the 4 subtopics, and that had been permutation and combination. Then the word problem related to the probability, stats, and then probability distribution and probability density. In the next slide, I had started with the permutation and combination. As far as the symbolic representation of the combination is being concerned, it's been referred as an NCR. What is the actual mean of NCR? The number of ways the R item can be selected out of n number of items. Similarly, the selection could have also been referred by the collection of withdrawn. As the n and r are been the number of items or the counting, so definitely they are being a whole number. Now, out of n number of items, r number of items are being selected. That means the value of r is supposed to be lesser than n, or at worst it could be same. So obviously r is going to be lesser than equals to of n. NCR, it talks about the number of ways. Number of ways. Is that part here? Number of ways. Number of ways. Number of ways. So obviously, as we had been talking about the number of ways, it could be 1 way, 2 way, 3 way, so on and so forth. Mathematically, NCR has been defined as a n factorial divided by r factorial n minus of r factorial. From where that formula had come, definitely we are going to discuss about that derivation itself, because what I feel most of the student understand combination as n factorial divided by r factorial n minus of r factorial, and npr is equals to of n factorial divided by n minus of r factorial, and that is why you people are not great in permutation and combination, and end of the day you guys are not great in probability. So until and unless you do not exactly know the physical fundamental of counting and from where these two formulas are been deduced, probably you will not be actually able to enjoy the permutation and combination. That is my responsibility. You will go into that level as well. Similarly, along with NCR, I had talked a bit about NPR as well. What's been the difference? In NCR, only and only collection has been the concern. Whether you had selected A and B, whether the A had come first, whether the B had come second, I do not worry about it, because the order does not make any sense for me. If the order do make sense for me, so obviously it becomes NPR, and if the order do not make any sense for me, it becomes NCR. Like we had taken an example, the 3 number of people we had, the peoples are been A, B and C. How many ways the 2 people could have been selected? Nowhere I had said their order also makes sense. So what I am going to do, I had taken 2 blocks. In first block we had got the opportunity that the all 3 person could have been filled the first block, but if first block is being occupied or it had been stagnant, obviously the second block would be left out with 2 only. So how many possibilities we had? Now one basic mistake you guys do is being, they used to add them together. No, my dear friends, it's been a branch or tree structure. A could have come with a BC, B could have come with a AC, and C could have come with AB. So total 6 number of opportunities we had. May I know what had been the 6? The 6 is being the number of ways 2 person can be selected and ordered out of 3 number of people. Obviously that is why AB and BA had been counted as 2 different selection. That means the order do also make sense. So the result has been 6. So many other times I had seen the student do the calculation in this way, and they would say, sir, 6 different way, my dear friend. This has been 6 different way where the order is also being regarded as the different selections. AB and BA had been taken as 2 different selections. But if you want to null them down, that means their order should not make any sense. In that case, what happens? Whenever the A and B had been selected together, forget about their order, just focus where the A and B had been selected together. So obviously it had been AB and BA. So you take this as 1, take this as 1, take this as 1. So now the number of ways the 2 person can be selected out of 3 number of people is just been null down to 3. And if you use the formula of combination, you got the same value. And even you had used the formula of permutation, you got the same value. you have got the same value. Yes, in the same sequence we had moved forward. We had taken an example, like we had taken an example if Indian cricket team is going for play for next T20 World Cup. So they had the 15 number of player, and out of 15 number of player they had to select 11 final 11 playing players. In that case, what had been happening? In this problem, we had just been focusing over the selection, collection or withdrawal out of 15 number of players. Nowhere the ordering had come into the picture. So now one big doubt do come into the picture. So whether should I be using the concept of permutations or should I be using the concept of combination? My dear friend, obviously you should be using the concept of combination only, because the order hardly makes sense. But in next problem, what I had done deliberately, out of 15 number of backup players, I had asked you to make a batting order. As far as the final batting order is being concerned, first you had to select 11 number of players out of 15 number of players, and then only you had to decide something else. So obviously this problem had become a problem of permutation. This problem had become a problem of permutation. Now, mathematically, permutation is being written as NPR, where the N is being total number of items, R is being the selected number of items. What had been the difference between NPR and NCR? The NPR talks about the number of selection with order. That means if the order is being changed, I would presume those different orders as the different selections. But in case of combination, they would be selected as one. NPR, how it's been defined? It's been defined as a n divided by n minus of r factorial, where the n has been total number of items, so on and so forth, Write it down. Few more important points. What had been that? As far as the NPR and NCR is being concerned, if you will focus over their formulas are yet to be derived. The NPR is being equals to of n factorial divided by of n minus of r factorial, whereas NCR has been n factorial divided by of r factorial into of n minus of r factorial. So virtually speaking, NPR is equals to of NCR into of r factorial, where r is been the number of selected items. Could be 1, could be 2, could be 3, could be 4, even could be 0 as well. So as far as the r factorial is being concerned, the value of r could be 0, 1, 2, 3, 4, 5, 6. That means this multiplier factor would always be 1 or greater than 1. So one thing is being quite sure, that the value of NPR would always be greater than equals to of NCR. Did you understand what I'm saying? Even if you want, you can take an example of out of 15 number of players, 11 had been selected, and similarly batting order is been made. NPR would always be greater than equals to of NCR. May I know when the NPR would be equals to of NCR? Do you have any idea when the NPR is going to be equals to of NCR? NPR is going to be equals to of NCR where the value of R is being 1. Because if R is been 1, 1 factorial is been 1, and if 1 factorial is been 1, NPR is been very same as NCR. May I know why the NPR and NCR is been very same when the value of R is been 1? Because if out of n number of item, let's take A, B, C, total n number of items you had, only one item you had selected. And now if you talk about their ordering hardly make any sense, because at a time only and only one item is being selected, so you cannot order them now. Isolately you will select A, isolately you will select B, isolately you will select C, but the ordering feature is not being coming into the picture. And even if you will withdraw one item, then also ordering is not coming into the picture. So one thing has been quite sure, if out of n number of item, one item is being selected, ordering does not make any sense, because ordering will make sense until and unless, or ordering will make sense when at least 2 items are being selected. In that case, their order could be A, B, and their order could be B, A. Did you understand what I'm saying? Yes or no? Now, a few more important facts. May I know what would be NC1? Because these are been important outcome which everybody should have there in mind. should have there in mind. Yes. NC1. How many ways one item could be selected out of n number of items? I could have selected A, I could have selected B, I could have selected C, I could have selected D. Put together, there are n number of ways I could have selected the one item out of n items. So from here onwards, what I'm saying, whenever you have this expression in your mathematics or maybe in aptitude 5C1, 6C1, there you need not to focus anything, just whatever the data you had, that data is going to repeat over there. That data is going to repeat over there. Not only that, if you take the reference of NP1, may I know what would be the worth of NP1? NP1, again, one item is being selected out of n item, and now their ordering would also make sense. So out of n number of item, you could have selected first item, second item, third item. How many ways this selection must have been done? N different ways the selection must have been done. And even the ordering would also make sense. My dear friend, only and only one item is being selected. So hardly the ordering is making any sense. So may I know what would be the value of NP1? What I'm saying, most of the student might be trying to understand this NC1 from the formula. They must be writing n factorial divided by of n minus of 1. No. Try to understand each and individual outcome with the help of practical significance. Yes. So may I know what would be the NP1? N again, N again. Mathematically, if you want to prove NC1, you could have written this as NC1, you could have written this as n factorial divided by of n minus of 1 factorial and 1 factorial. Now the n factorial could have been written as n minus of 1 factorial into of n, और नीचे है n minus of 1 factorial into of 1 factorial. ये गया और आपके पास अभी भी डेटा जो बच रहा है वो कितना है, n. Is that part clear to all of us? What exactly I wanted to communicate through this? Now I had taken a next situation, NCN. May I know what would be the worth of NCN? Let's say you had the n number of datas, n number of items, and all together has been selected. May I know how many ways you could have done that? Obviously one way. Let's take you had alphabet A, B, C, D, E, F, G, H till n. If all of the n alphabet has to be selected together where the order do not make any sense, how many ways you could have done? Obviously this has been simply one. So what I'm saying, from here onwards, whenever you had the problem like 5C5, maybe 6C6, the worth is been simply one. Worth is been simply one. Agreed? So I don't find any of the student would have any kind of doubt from here onwards. See, now try to understand how NPR had become n factorial divided by of n minus of r factorial. Let me focus over the little bit part of derivation. Derivation, because once you know this derivation, you know most of the things. Derivation. So solution do starts from here. Let's take, you had three number of items, and you had to select and order two number of items. Select and order two number of items. Subhangi Gupta, sir, can we use always permutation where there is no repetition? I will tell you, Subhangi, because approximately 20 number of cell design problem I had from the permutation and combination. Once you'll see those all problems, so literally end of the day, you won't be able to say that. Would you like to see how many questions I had planned? See, just have idea. Just have idea. How many number of questions I had planned? See, these all questions are based on concept of permutation and combination. Almost 10 questions are been there in each and individual. So here, probably you won't be able to see approximately 10 number of PDFs we had, and in each PDF approximately 10 number of questions we had, approximately 100 number of questions I had planned. See, so what had been happening over here? As the selection of the two item has to be made, obviously the two block is being made available. In first block we had the possibility of 3, in second block we had the possibility of 2. How many ways the final selection and ordering can be made? And that's just been the multiplication of 3 and 2 that we had already seen. We had taken the reference of ABC. So how many ways the two alphabets can be selected with its order? We had already seen the value is been 6, that we had already seen. Similarly, from where this outcome had come and how do we connect with this equation, that we want to know. Try to understand how the 6 must have come. See, in first block you had the possibility of 3. In second block you had possibility of 2. Virtually speaking, you had the possibility of 3 factorial divided by of 3 minus of 2 factorial. Obviously they are one with the same, they are one of the same. Like if I take the another example, let's take it's been the 4 item is been there, and out of that the 2 items are to be selected and ordered. So what we had been doing, now we are going to take the 2 number of blocks. In first block we had the possibility of the 4 items where the first item is being occupied in first block. So obviously you had been left with 3. What had been the result over there? Well, how did it come? It has been 4 into 3. But how it had been 4 into 3? See, actually it had been 4 into 3 into 2 into 1 divided by 2. So may I know what had been 4 into 3 into 2 into 1? That is been 4 factorial. And what had been 2? That is been 2 factorial. Virtually or mathematically this has been n factorial divided by of n minus of r factorial. Let's take another problem. We have 5 items. Out of that, the 3 items is to be selected and to be ordered. So how many number of blocks we are going to have, my dear friends? The 3 number of blocks we are going to have. In first block we had the possibility of 5 items. 1 item is been fixed in first block, so obviously we had been left with 4. And now the another 1 item is been fixed in second block, so I had been left with 3 only. Yes. So may I know what had been the result? Don't focus over the numbers, focus over the process, focus over the understanding. So the result has been 5 into 4 into 3. May I know how the 5 into 4 into 3 can be deduced from the mathematical formula? My dear friend, probably this should have been 5 into 4 into 3 into 2 into 1. Yes, 5 into 4 into 3 into 2 into 1. So probably it must have been 5 factorial. But the remaining part of 2 and 1 has been knocked off. And how 2 factorial is supposed to come? This is supposed to come if 5 is been subtracted with 3. Virtually speaking, it is again been n factorial, n minus of r factorial. So did you really understood from where the formula npr is equals to of n factorial divided by of n minus of r factorial had come into the picture? Obviously out of 3 items, 2 items are being selected. How many ways it could have been done? In first block this could have been 3, in second block it could have been 2. Put together it's been 3 into 2, and 3 into 2 could have been written as a 3 factorial divided by of 3 minus of 2 factorial. Virtually speaking, it has been n factorial divided by of n minus of r factorial. Out of 4 items, 2 items is to be selected as well as the ordered. How many ways it could have been done? In first block it could have been 4, in second block it could have been 3 only. Put together It had been 4 into 3. 4 into 3 could have been written as a 4 factorial divided by of 2 factorial. Virtually speaking, 4 factorial divided by of 2 factorial has been the subtraction of n and r. Put together, it's been n factorial divided by of n minus of r factorial. Similarly, if you take another situation where the 5 items are being there, out of that the 3 items is to be selected and is to be ordered. So how many ways I could have done? This has been 5 into 4 into 3. Obviously the result has been 5 factorial divided by a 5 minus of 3 factorial is equals to of n factorial divided by of n minus of r factorial. N minus of r factorial. So did you have the clear cut idea? So I would like to know how the NCR had been n factorial divided by of r factorial n minus of r factorial n minus of r factorial. See, this has already been concluded because in permutation this factor is already had come, n factorial divided by n minus of r factorial. But we will try to understand why the r factor had come towards the denominator when we had been calculating the combination. My dear friend, just try to understand. If you are taken this situation, see, if you had taken this situation, in this situation out of 3 items the 2 items are being selected. Let's take, they must have been AB, they must have been BA. But what had been happening, my dear friend? AB and BA, although had been taken as the 2 different selection when their orders are also being regarded, but when their orders are not to be regarded or they has to be taken as one, so this 2 blocks must have been taken as one. So obviously the 2 must have been divided towards denominator side. Did you had idea about it? Yes sir. 2 has to be divided towards denominator side when the order is not been regarded. Yes, when the order is not been regarded. Similarly, out of 4 number of items, again the 2 items are being selected. Again, there also the 2 items which are being selected, their different orders must have been taken as different selections. And now if 2 orders which are being taken as 2 different selections are to be merged together, again the 2 has to be divided. Not only that, even if 3 items are being selected, 3 items are being selected like ABC. ABC could have been selected in 6 different ways. It could have been ABC, it could have been ACB, it could have been BAC, it could have been BCA, it could have been CAB, it could have been CBA. But as far as the combination or collection is being concerned, they had to be regarded as one only. So how many packet would be made? This would be made as 3 factorial. Earlier it had been made as 2 factorial. In future it would make at 4 factorial, so on and so forth. So virtually we can say whatever the result we have got it in a form of NPR, that has to be divided with the R factorial, so that the different selections where the collections were same but the orders were different had been made one. So I would like to ask from each one of you, would you like to have few number of questions for the homework? So let me take few number of questions now. So that questions would go as a form of homework. So where it comes, here it comes. No, Manoj. Sir, will this video private? No, it won't be. It won't be. So let me take the first question. The number of ways 2-digit long number can be fabricated using 2, 3, 4, 5 without repetition. Tell me how many number of ways? How many number of ways? Only 2 questions I am going to take in today's class, and then we will continue from tomorrow onwards. Tell me whether this has been a problem of permutation or combination. That you tell me first, and then we will move forward. Whether this has been a problem of permutation or combination. Whether this has been a problem of permutation or combination. I would like to have the input from each one of you. Whether it has been a problem of permutation or combination. Only one answer we had received so far. Tell me. It's been a problem of permutation or combination. It's been a problem of permutation. Why so? Because if you'll select the data, if you'll collect or combine the data, what would happen? If 2 and 3 had been selected together, but 2 then 3, 3 then 2 are been making the two different numbers. What had been asked in this problem, out of this 4 different digits, how many ways 2-digit long numbers can be made? So out of 4 digits, if 2 digit 2 and 3 is being selected, 2 then 3, 3 then 2 are been making the two different numbers. That means here only and only collection selection do not exactly make sense, even their order also do. Even their order also do. Yes. No, 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 no. Subhangi Gupta, I would repeat once again what had been asked in this problem. The number of ways 2-digit long number can be made out of the 4 digit without any repetition. So what I have been doing, out of this 4 numbers or 4 digits, if 2 and 3 is been withdrawn, may I know if 2 had come first and then 3 had come, and 3 had come first then 2, whether they had been making the two different numbers or not? Obviously, sir, that means here only and only combination is not coming into the picture. Even their order do also make sense, specifically when the collection and selection of different numbers are being concerned. Most of the time the problem do go towards the side of permutation, Did you understand, Subhangi? I would like to ask from each one of you, did you have a clear-cut idea about this problem? Out of 4 digits, we had to select the 2 digits, and that selection as well as the ordering would make the different numbers. So may I know what are they? So out of 4 digits, the 2 digits are to be selected. Not only the selection is been important, even their ordering is also been important, because 23 and 32 are been the two different number, 34, 43 is been the two different number, and similarly 45 and 54 are been the two different number. So for P2, it's been quite straight, and that had been 4 factorial divided by a 4 minus of 2 factorial, that is been 2 factorial, and it is going to be 4 into 3 into 2 into 1 divided by 2 factorial. It's been 2, and the result which we are supposed to get, it's been simply 12. It's been simply 12. Now let me focus over the second question. How many ways the two balls can be picked from the container having 3 numbers of ball? 3 numbers of balls means the quantities of the balls are being 3. So I would like to ask from each one of you whether this has been a problem of permutation and combination. If you had a gut feeling, or if you had a clear-cut idea where the problem go into the side of permutation, when the problem do come into the side of combination, just formula is to be used and you will be getting the answer. Subhangi, tell me whether the permutation to be used or the combination to be used. Obviously the combination to be used, because if you had how many number of balls? 3 number of balls. You could have selected this 2 ball once, you could have selected this 2 ball once, you could have selected this 2 ball once. So how many ways the 2 items could have been selected out of 3 items? That had been simply 3. So without using even combination and permutation, you could have got the answer as well, because here the ordering had not been made any sense. Like out of 50 number of players, you were selecting 11 number of players, their ordering had not been any sense, at least at that problem. Yes. So here what had been happening, as far as the problem is been concerned, it's been a problem of combination. Out of 3 number of balls, we are going to select 2 number of balls, and where their order hardly makes sense, at least in this problem. So this has been 3 factorial divided by of 2 factorial, 1 factorial, and put together the result is been 3. Yes. Okay, then in the same sequence, let me take the next question as well. How many ways a 4-digit long even distinct means different numbers can be fabricated using 2, 3, 5 and 7? One of the well designed problem. How many ways a 4-digit long even distinct number can be fabricated using 2, 3, 5 and 7 without any repetition? Without any repetition. Tell me what could have been the best most answer. Permutation, obviously permutation. But here one additional information is also being supplied with the problem, which also to be followed, which is also to be followed. See, how many ways a 4-digit long even distinct number, even, my dear friend, that means we had to make a packet of a number which should contain the 4 digits. And being an even number, out of 2, 3, 5 and 7, the 2 is been fixed in the last block of this 4-digit long number, because being an even number, the first number has to be either 2, 4, 6 or 8, or has to be a even number. And as far as the 4 digits which had been supplied along with this problem are being odd and even, so 2 is been fixed at this place. It cannot move from its place. No, it cannot move from its place. Now you had been left out with only and only 3 space. You had just been left out only and only 3 space. So here we had 3 possibility, here we had 2 possibility, here we had 1 possibility. Put together the result is going to be 3 into 2 into 1, that has been 6, or 2 is been fixed. So how many number is been left out? Only and only 3 numbers are being left out. So 3 numbers to be selected and to be arranged. How many ways it could have been done? We have already seen npn is equals to of n factorial, and that is being simply equals to of 3 factorial, and that is being equals to 6. That is being equals to 6. Should I repeat this fundamental once again? How many ways a 4-digit long even distinct number can be fabricated using 2, 3, 5, 7? The important wording which has been connected along with this problem is being even number. The number has to be even. That means this 2 had been fixed at its place. It cannot move from its place. So obviously permutation and combination would not have any impact because of 2 and its units place. Only and only movement of 3, 5 and 7 is going to take place, and if their movement is going to take place, still it would again be a even number. Again be a even number. So yes, the answer has been 6. So from tomorrow onwards, keep in mind, we will be live exactly at same time as we had done it today. And for the better detail, you can also connect with me on my telegram group. So this has been my telegram group. Yes, t.me plus abcd 123 df 123 df. Okay, so we will meet tomorrow precisely at 7:30. Till then, bye bye, take care.